The topic of the report, redox reaction. The report was completed. The students Meruert, Sanim, Gulbanu, and Gulbada. So, what is redox reaction? A redox reaction can be defined as a chemical reaction in which electrons transpirate between two reactions, propertying in it this. Transfer of electrons can be identified by observing the changes in the oxygen status of the reaction spaces. So, types of redox reaction. First, decomposition reaction, combination reaction, discombinate reaction, and next, disproportionation reactions. Next, oxidation and reduction. In order to understand redox reaction, let us first deal with oxidation and reduction reactions individually. What is the oxidation? Oxidation may be defined as the loss of electron from a substance. The other definition of oxidation reaction states the addition of oxygen or the more electronegative element, or removal of hydrogen or the more electropositive positive element from a substance is called on oxidation reaction. So, what is reduction reaction? Like oxidation reactions, reduction reactions are defined as gain electrons. Any substance that gains electrons during a chemical reaction gets reduced. In other forms, the reduction reaction is stated as the addition or the more electropositive element or the removal of a more electronegative element or oxygen from a substance. Oxidizing and reduction agents. The substance, atom, ion, and molecule that gains electrons and is thirdly reduced to a low valence state is called an oxidizing agent. The substance that loses electrons and is thereby oxidized to a higher valency state is called a reduced agent.
Balancing redox reaction. There are two ways of balancing the redox reaction. One method is by using the change in oxidation number of oxidizing agent and the reducing agent, and the other method is based on dividing the redox reaction into two half reactions, one of reduction and another of oxidation. Balancing redox reaction by oxidation states method. This method is based on the fact that the number of electrons gained during the reduction reaction equals the number of electrons lost in oxidation. Redox reaction in combustion. Combustion is a type of oxidation-reduction reaction, and hence it is a redox reaction. An explosion is a fast form of combustion, hence the explosion can be treated as a redox reaction. Even the space shuttle as redox reactions. The combination of ammonium perchlorate and the powdered aluminum inside the rocket boosters gives rise to an oxidation-reduction reaction. Applications of redox reaction. Redox reactions have numerous industrial and everyday applications. A few of these applications are listed below. And the applications of redox reaction in electrochemistry. The battery used for generating current uses a redox reaction to produce electrical energy. Applications in photosynthesis. Green plants convert water and carbon dioxide into carbohydrates, defined as photosynthesis.
Classification of redox reactions. Number 1. Intermolecular redox reactions. In such reactions, the oxidizing agent and the reducing agent are different chemical elements and part of different reagents. For example, reaction between aluminum and chromium oxide, and we get chromium and aluminum oxide. Here, aluminum is the reducing agent because oxidized to 3, and chromium is oxidizing agent because it is reduced to 0. And number 2, Intramolecular redox reactions. In these reactions, the oxidizing agent and the reducing agents are different chemical elements, but they are part of the same substance. And for example, ammonium chromate decomposition, chromium oxide, and nitrogen gas and water. In this, here nitrogen is reducing agent because it is oxidized 0 to 0, and chromium is oxidizing agent because it is reduced to 3. Number 3, disproportionation redox reaction. This is for the name reaction in which both the oxidizing agent and the reducing agents are chemical elements same substance and the chemical elements. For example, sodium hydroxide and chlorine, and we get sodium chloride and sodium gypchloride and water. In this, chlorine is the oxidizing agent and the reducing agent because chlorine is reduced -1 and oxidized 1.
We find the oxidation stage. Here the degrees of oxidation of magnesium and sulfur have changed. Here now we balance by particle reaction. Since acid involved in the reaction, we added water to the side with less oxygen and the hydrogen protons to the side with more. Now we will write down those appearance in the coil ion. We appearance the same things. We equal the coefficient to the main reaction. Now we will balance using the ionic formula. Here get only the change elements and align with that. Manganese oxidation again reducing to 5, and sulfur reducing again and oxidation to 2. In this reaction we can find the oxidation stage that has changed its balance. It strong half reactions and ion spans. First half reactions. In the next reaction, since it's a base, we add hydrogen ion to the side with less oxygen and hydrogen to the side with more. We equate the coefficient to the elements and align with that. Now we balance using the ionic formula. Here we get only change elements and align with that. Manganese oxidation agent reducing to 6 and sulfur reducing agent and oxidizing to 6. In a natural environment, we use water for the reagent of an acid in format. After the reaction, we take a hydrogen proton, and if it's a base, we take a hydrogen anion. manganese oxidizing agent and the reducing to 2 and 2,4, and the sulfur reducing agent and the oxidation to 6.
Thank you for the attention.